Okay, so now after learning how to find the or sketch the graph for a polynomial function, let's find how to sketch the graph for a rational function. So in here we have steps to do. It's easy to find actually. So in here, starting as usual, which is by finding the domain. Now, before starting with finding the domain, I can just make these two expressions as one. So I'll make the denominators the same. Okay, so in here, I can multiply x by x, and this is going to give me x squared. 1 multiplied by 4, this is going to give me 4 over x multiplied by 1, which is x. Now, for finding the denominator, you know that if you have polynomial over polynomial, the domain, it will be r minus the 0 of the denominator, x equal to 0, so it's 0 only. Okay, now we can, just for sketching the graph, that will give you more details about your graph, which is finding the vertical asymptote, horizontal asymptote, slant asymptote, if you have any. So the vertical asymptote, you can find this by finding the zeros of denominator. Okay, now for the horizontal asymptote, we have a lot of methods for finding them. We can use the limit when x tend to infinity and x tend to minus infinity. You can also use the direct method as you like. Now in here, the horizontal asymptote, you can find it if you have polynomial in the numerator and polynomial in the denominator. If the degree of the numerator is less than the degree of the denominator, then you have y equal to 0 as horizontal asymptote. If the numerator, the degree of the numerator equal to the degree of the denominator, then you have y equal to leading coefficient over leading coefficient. Now, if you have the degree of the numerator greater than the degree of the denominator, then you have no horizontal asymptote. Okay, the last one, or the last type of asymptotes that we have learned, the slant asymptote. This is in case if you have the degree of the numerator greater than the degree of the denominator, okay, by 1, okay, or 2. Because recently we have learned how to find the quadratic slant asymptote. So if the degree of the numerator greater than the degree of the denominator by 1 or 2, you can find the slant asymptote. In here, these are the cases in general for finding vertical, horizontal, and the slant asymptote. So let's go back to our question. So in here, x squared plus 4 over x, the degree of the numerator, or before starting with the degree, let's talk about the vertical asymptote. The vertical asymptote over here as zeros of the denominator. So in here, x equal to 0 as a vertical asymptote. So after that, we can find the horizontal asymptote, okay, which is, we can check which case I have in here. Is it, so in here I have the degree of the numerator is greater than the degree of the denominator, which is case number 3, so no horizontal asymptote. The degree of the numerator is 2, and the degree of the denominator is 1. Now, slant asymptote, the degree of the numerator greater than the degree of the denominator by 1. 2 minus 1 is 1. So, in here, I can find this by using the long division. So, in here, okay, I'll use the long division. Now for the long division, put all the terms, even the missing terms, add them please. So in here, x squared, I must have after that term with x, then the constant. So in here, plus 0x plus 4. I know that you will tell me that, teacher, in here this is 0. I know that, but this is just to make your division more easier. So in here, divided by x. So since I have x, that means I have, or I should have what constant, which is 0. Okay, now divide by taking the highest over the highest. X squared divided by x, this is equal to x. And I will put the result above the similar term. So x squared over x is equal to x. So I'll put it above the similar. Similar for x is this, 0x. From degree 1, from degree 1. Now multiply. X multiplied by x, this is x squared. X multiplied by 0, this is equal to 0. Then parentheses, then minus, then start subtracting. X squared minus x squared is 0. 0x minus 0, 0 as well. So I will take the 4 downward. Now you will check the degree of the remainder. If it's less than the degree of the divisor, خلاص you can stop the division process. So 4 is from degree 0. Okay, this expression from degree 1. So I can stop the division now. And I can say I have slant asymptote, which is y. That's it. So it will be y equal to x. This is my slant asymptote. Okay, now we have finished finding the asymptote, so we can move directly to solving the question as we do usually. So f prime is equal to, we have to find the derivative of that. So the derivative of the denominator, which is 1, multiplied by the numerator, x squared plus 4, minus the numerator. So it will be the denominator multiplied by the derivative, sorry. So it will be over here again. Okay, yes. Okay. So the denominator multiplied by the derivative of the numerator, which is 2x, minus the numerator, x squared, plus 4, multiplied by the derivative of the denominator, which is 1, over the denominator square. Now let's simplify it a little bit. So this is 2x squared minus 2x squared, yes, minus x squared minus 4 over x squared after entering the minus inside this. So 2x squared minus x squared, this is equal to x squared minus 4 over x squared. Okay, now we can make the derivative equal to 0. Okay, now after making the derivative equal to 0, the zeros, okay, the zeros, we can find them from the numerator. So we can factorize actually the numerator. You can use your calculator for that, or you can find the factors directly. This is difference between two squares. So x minus 2 times x plus 2 equal to 0. And that will give me x equal to positive negative 2. Okay, now what about the undefined value? We can find this by making the denominator equal to 0. So x squared equal to 0, that will give me x equal to 0. Now this is accepted by me, which is positive negative 2, because they are included in my domain or the original function domain. But the x, it will be excluded or rejected because it's not included with the original function domain. So now all we have to do is the number line test for the first derivative. Okay, so in here I have minus 2. Even the 0, it's not included with me. I rejected this value, but just in case, put it on the number line. Okay, I know it's not, it's useful because it will help you all the time in finding your graph. So even there is no value over here, it's rejected, just put it on your number line. So 2. So in here I can test the signs of the derivative between these values. Okay, so I'll go directly to the calculator, and I have over here the function or the derivative, which is equal to x squared minus 4, not a plus. Okay, now calculate at a value less than minus 2, which is minus 3. Okay, this is going to be positive. Okay, so in here I have positive value. Okay, let's see another one. Calculate at value between -2 and 0. Let's see -1. So this is negative. Okay, so let's see a value between 0 and 2. So calc at 1. So this is negative as well. And I believe if we have a value greater than 2, so, so let's calculate at 3, for example, is positive. So in here we have positive. So up, down, up, down. Okay, now we can say that the function is increasing from minus infinity to -2 union with 2 to infinity, and decreasing from -2 to 0 union with 2 or 0 to 2, 0 to 2. Okay, now we can find the critical points, which is, I'll use positive negative 2 only. So -2 and what, and 2 and what. We can find them directly by substituting in the original function actually. So -2 squared, this is equal to 4, 4 plus 4, which is equal to 8, 8 over -2, which is equal to -4. And if you substitute in the original function the 2, it will be 4. Okay, that's it. So in here we have the critical points.